Okay, class, welcome back. Today we're going to dive further into the topic of moles. Yes, today we're going to involve math, and to be honest, for the next few units, it is significantly composed of math. So you might as well just get used to the fact that math is sticking around in chemistry. My objective for you today is that you would be able to convert the mass of an element to the moles of that element and vice versa. In saying that, let's dive into what we have for the day. In our past video, we talked about how moles is the SI unit of representing the number of representative particles within a fixed amount of a substance. Today we're going to take another route with mole problems and talk about how mass and moles are related. We know 1 mole of carbon is 6.022 times 10 to the 23rd atoms of carbon, but how do we go from moles of carbon to grams of carbon? This is done by using the molar mass of carbon. The molar mass is simply the amount of grams of a pure substance in 1 mole of it. In the case of carbon, there is 12.01 grams of carbon in 1 mole of carbon. When we look at each periodic square in the periodic table, there is a decimal number that represents the atomic mass of the substance. We use the atomic mass as the molar mass. So, if we look at a periodic square for the element lithium, we see there is 6.94 grams of lithium in 1 mole of lithium. For most calculations, we can round up to the nearest whole number. So in this case, we would say that there is roughly 7 grams of lithium per 1 mole of lithium. In problems, we can represent this as 7 grams of lithium over 1 mole of lithium, or 1 mole of lithium over 7 grams of lithium, depending on what the problem is wanting us to solve for. Now that we have a way of knowing how many grams of a given element there are in 1 mole of that element, we can start solving problems for masses. These problems are set up like our atom problems in a way that you start off with writing down what you know or what is given over 1 and multiplying it by the relationship between moles and masses, in other words, the molar mass. So, let's say I have 50 grams of sodium and I am wanting to figure out how many moles of sodium I have. All I would have to do is put my known value over 1, so 50 grams of sodium over 1. Then I would multiply it by the molar mass relationship. Since I am wanting to get to moles and I want to cancel out grams, we would use the molar mass relationship of 1 mole of sodium over 22.9 grams of sodium. Or if you want to be approximate, you can say 23 grams of sodium. When we do this, we get roughly 2.2 moles of sodium in 50 grams of sodium. Now let's say we are given the moles of sodium and we were wanting to go to mass of sodium. Well, all we are going to have to do is the same step, but instead of using the molar mass relationship of 1 over 23 grams, we want to use 23 grams of sodium over 1 mole of sodium. So let's say we are wanting to see how many grams of sodium are in 0.87 moles of sodium. We would put what we know over 1, so 0.87 moles of sodium over 1. Then we would multiply it by the molar mass relationship of 23 grams of sodium over 1 mole of sodium. This would give us 20.07 grams of sodium. Now you should be able to convert to and from moles when given the mass of an element. Before we end the day, we need to discuss one more topic, and that is diatomic molecules. The word diatomic means 2 atoms. These elements, if found in their purest form, are found in sets of 2. They include hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So if I had pure oxygen, I would have O2. Or if I had pure iodine, I would have I2. What is important to understand about this is that on the periodic table, the atomic or molar mass given is for a single substance. So the molar mass of oxygen is 16 grams per mole. The issue with diatomics is that diatomics are found in sets of 2. So because of that, we're going to have to multiply our atomic mass by 2. So our molar mass of 1 mole of pure oxygen, or O2, would be 16 times 2, or 32 grams per mole. This becomes important and can trip you up if you are not careful. So make sure you are paying attention to the type of molecules or atoms present within a question. Okay, that is enough for this lesson. It honestly was not too bad, so I hope that you were able to get this concept on lockdown. We will be using these steps of getting from atoms or grams to moles and back frequently from now on. So if you do not get it now, it is probably a smart move to start asking questions. In saying that, keep up the good work in the classroom, and see you next time.